Here we have question number 34. It states that 2 cosine of 2x plus 1 is equal to 0. So we want to solve this. And so obviously we can set, we know that cosine of 2x, right? We can move the negative 1 and the 2 on the other side. So we see that cosine of 2x is equal to negative 1/2. Negative 1/2, right? Now the thing here is, if you recall again from one of my previous lessons, I said that you want to say that some variable is equal to 2x, and then solve from there, and then do plus 2 pi n is equal to 2x, right? That's the best way to determine all the possible angles that satisfy this equation over here. So we can obviously say that let u is equal to 2x. So we know that cosine of u is equal to negative 1/2, right? So we know that u here, right? So if we're looking at a negative value, we're looking for cosine, we know that quadrants 2 and 3 is what we're looking at. And we know that pi over 3 is where we have cosine of pi over 3 is 1/2, right? So we're looking at 2 pi over 3, right? And then we're looking at 4 pi over 3, right? Because this is in quadrant 2, this is in quadrant 3. So obviously with the reference angle of pi over 3. So these are two possible values for u. Now we know that 2 pi over 3, right? 2 pi over 3 plus 2 pi n must give you 2x, right? This was x over here. And so we can solve this obviously. And so we see that we can obviously divide both sides by 2, right? So we get x is equal to 2 pi over 6 plus pi over n, plus pi, not pi over n, sorry, plus pi times n, right? Because we did 2 pi n over 2 is just pi times n. And so we can do the common denominator here. So we know that x over here, so we know that's just pi over 3 plus pi n, right? So we can have a common denominator of 3 here, so we can say that pi plus 3 pi n divided by 3, right? So that is the first equation that we're looking at, right? And then for the second one, we know that we had 4 pi over 3, so let's take that one. So we have 4 pi over 3 plus 2 pi n is equal to 2x. And so we do the same thing. We divide both sides by 2. So we do that, we get 4 pi over 6. Now that's just 2 pi over 3, right? Because you have 4 pi over 6, that's just 2 pi over 3. And then you have plus pi times n. And so you see here that x is equal to, again, use that common denominator of 3, right? X is equal to, so you have the common denominator of 3, and you have 2 pi plus 3 pi n. So you have these two equations over here, right? Your equations are x is equal to pi plus 3 pi n all divided by 3, and then you have x is equal to 2 pi plus 3 pi n all divided by 3, right? I'm talking about these two equations over here. So we can already solve this because we have our two equations for which we have defined x, right? And now what we're doing is because n here is just your integer value, and so you want to see all possible, you want to plug in 0 for n, then you want to plug 1 in for n, then 2 in for n, and really all x values satisfy as long as it's not going over 2 pi, right? As long as your x value is not, as long as you're not getting something like, I don't know, you're not getting something like 19 pi over 2, right? It has to be within that range from 0 to 2 pi that we're looking at. So here we can say that x is equal to, put 0 in for n, right? We get pi over 3. Put 0 in for n, we get 2 pi over 3. Now you can put 1 in for n, you get 4 pi over 3. Now you can put 1 here as well, so you get 5 pi over 3. So we have these 4 values. Now put n is equal to 2, right? You get 7 pi over 3, right? Well, you know that 6 pi over 3 is equal to 2 pi, which is 1 revolution about that unit circle. So 7 pi over 3 will not fall under our restriction, right, that we have. So we're looking at these 4 values here. So the solution here to question number 34 is x is equal to pi over 3, comma 2 pi over 3, comma 4 pi over 3, comma 5 pi over 3. So thanks for watching.